this video, I'll just show you how you can use Python to do machine learning algorithms on an arbitrary data set. So as you can see, the social network ads.csv, it's here. Um, and this is the sample data set which we will be using. This is just an example. You can have your own CSV, and this would still work as long as your CSV doesn't have any words in the feature sets. So I'll just explain what's a feature. A feature is just columns. So user ID is feature 1, gender is feature 2, age is feature 3, estimated salary is feature 4. Purchase is your Y. So that's the final thing. So since this is a classifier, all we have to do is train our model on 80% or 70% of this data set, and then we will use the rest of the data set to see if it can give this output. The correct output is this one, right? This is just an example. So let's go back to the code. By the way, this code will be uploaded in GitHub. It will be in the video description. You can just go over there and download it. And I'm using Visual Code for this. You can use Spider, Anaconda Navigator, Jupyter Notebook, whatever you are comfortable with. So the way it's going to work is you just need these three things, right? MATLAB, Plotlib, NumPy, Pandas, and this one, sklearn is what you need. Once you have pip installed all of these, then this code should work. So you just go with dataset, you just load up this social network ads.csv, and then you specify what is your X. Notice that I'm going column 2 to column 3. That means that my columns would be 0, 1. I want this column, age, and the estimated salary 3. Just because we just ignore the gender, makes it a bit easier, because if with gender you just have to change it. It doesn't like words. I know this for a fact because I've used this. For that, there's something else. But if you got numbers in your feature sets, this would be fine. So yeah, we just take this SX to these two columns, and then Y is this one, which is shown here. Once you do that, you just have to go splitting data set into training and test set. So in this case, we've got 25% as the test set. The rest of it, the 75%, is the training set. Standard scaler, it's good. Feature scaling, just look at this, right? Machine learning just loves small data set. That means that you just have to normalize all of this data. It just likes small numbers. Even if you go with deep learning, like with with images, we use small images. If we try training the model with large images, like from an iPhone, these days, it doesn't like it. It doesn't do well with it. So just keep that in mind, that machine learning and deep learning, they like small data set. So yeah. So now in this case, we just use random forest classifier. That's it. This is just the line of code which you will have to keep on changing. So this is a forest classifier, and then I just want to get the confusion matrix and to get automated accuracy. I just want to get the accuracy, right? So I guess I'm using forest classifier, but I've called it accuracy forest. Actually, I'll just see, and then accuracy forest. Yeah, okay, just to make sure that it just, it's Windows, it's Visual Studio. So let's have a look. So yeah, so accuracy is 91%. Forest gives us good accuracy of 91%, right? And that's the graph. For me, I just go with accuracy. You can look at the graph, you can look at the confusion matrix. This diagonal is good for you. So this is 63, true positive or false positive. This diagonal gives you those, and these are true negatives, I think, on the other diagonal. This would just be confusion matrix images. So yeah, so yeah, true positive, true negative, false negative, false positive. So you just look at those diagonals. So yeah, so that was your tree. So you go to Canaan. What do you change? You just change this section of the code. It depends on what nearest neighbors you want. The metric Minioski, it's a standard one. There are other metrics. You can look inside this. You can dir on this sklearn k nearest neighbors, or you can just do a small Google search. So yeah, let's have a look at the k nearest neighbors. So Canon is giving an accuracy of 0.93%. Oh, sorry, 93%. So that's pretty cool. We just wait for the graphs to populate, and yeah, that's the graph. It's a bit slower because it does Canon can slow. Canons are quite slow in machine learning algorithms because it has to plot it and it has to find the nearest neighbors of that. Then we look at the naive Bayes, which again we just change only this section of the code. Nothing else changes, so we accuracy is 90%. And that's it. Then we go SVM. Again, you just change this section of the code. Again, this kernel and all that, you can change these things. You just have to look into it. It's on a use-based thing. This is a very easy example, but it gets you in the right track. That's SVM 90% again, and then tree classifier, right? And then you just go here. So yeah, this is the tree classifier, and we get 91%. So yeah, so just to give you an intuition, because I don't know what your use case would be. Forest classifier loves big data set. It works like decision tree, except with forest you just have multiple trees. That's why it's called a forest, and it loves big data set. KNN and SVM use them for small data sets. SVM can work well with moving parts. I did a project where if things are moving, SVM is really good for it. I think in Japan they use SVM to check on the coolant of a nuclear plant. So it's pretty accurate, it's pretty good for moving things. But if you've got huge data set like deep learning, SVMs is not your go-to thing. For that, it's neural networks, which are not here, but you can use that as well. Tree classifier, again, it's good for big data sets, and it's very quick. It's super quick for big data sets. SVMs and KNNs would struggle with those. So yeah, I hope this makes some sense to you. I just want to keep this short, keep it pretty informal. But yeah, this carries a punch because if you can just do this, your lecturer or your teacher would be very happy. So yeah, I hope this makes sense.